Okay, this problem is an example of a very similar problem to question 4 in chapter 7, suspended solids concentration. One thing that the question doesn't mention that you need to know to solve the problem, whenever we're measuring suspended solids in wastewater, we want our final answer to be in milligrams per liter. Having said that, let me explain to you really quickly as a refresher how this test is done. A Gooch crucible is just a ceramic crucible with holes in the bottom. And what we do is we put a paper filter in the bottom of this crucible and then we weigh it. So that would be our initial weight, would be just the crucible and the paper filter. So that's our initial weight. Once we've weighed the empty crucible, we will pour a certain amount of sample through it. In this problem, it would be 80 milliliters of sample we would pour through that filter. Any suspended solids are going to get caught in the filter. After we pour the sample through the filter, we would put that crucible in a drying oven and evaporate any water in that paper filter, and then we would weigh the crucible again. And then the final weight, we're going to subtract our beginning weight here from the ending weight, and then use that number to calculate the suspended solids concentration. So the very first thing that we're going to do to solve this problem is we have to subtract the ending weight. We have to subtract the beginning weight from the ending weight. So let's go ahead and do that. So we have 23.0065 grams minus 23.0021 grams. So we have 0.0044 grams. Now, this is where I'm going to point out the importance of knowing that this final answer is going to be in milligrams per liter, because our weight is in grams. So after our first step of subtracting, we need to convert this weight of the suspended solids from grams into milligrams. And if you remember from high school, or if you don't remember, if you look on one of your formula sheets, you're going to find that there are 1,000 milligrams in a gram. So we are going to multiply our answer here in grams by 1,000 to convert it to milligrams. So we want to take our 0.0044 grams times 1,000, and that is going to get us to 4.4 milligrams. Now, the second thing that I'm going to point out, because my personal experience from doing problems like this in our lab, when I was not able to look a formula up, was trying to figure out how to solve this problem just by knowing a little bit about the metric system. So one of the reasons that I keep pointing out that when you see this word per is that you have a division problem is I can use that now to solve this problem, because I want my answer in milligrams per liter. And I've already converted the weight of my sample into milligrams. So I have 4.4 milligrams, but right now I have 4.4 milligrams per 80 milliliters of sample. But I want my answer to be in milligrams per liter. So I have to convert 80 milliliters into liters. And just like there are 1,000 milligrams in a gram, there are also 1,000 milliliters in a liter. So a very easy way to do this is to take the volume of my sample, or 80 milliliters, and divide it by 1,000. And I can convert that 80 milliliters into 0.08 liters. So now that I've converted the weight of my solids into milligrams, or 4.4 milligrams, if I divide that by the volume of the sample converted into liters, or 0.08 liters, I will get an answer in milligrams per liter. So 4.4 divided by 0.08 equals 55 milligrams per liter. So without having the benefit of a formula sheet anywhere and just basically understanding how the experiment is done, you can figure out how to do this problem. So that is the way that I would approach a question like problem number 4.